I'm Françoise von Trapp with 3D Insights, and I'm here today with Antoine Ahmad from Entegris, and we're talking about the new collaborative approach, and he's going to explain a little bit more about that. But first, why don't you explain to me what is the impact that the semiconductor industry is having on the automotive industry?
The automotive industry is in a big transformation phase, Françoise. Just because the amount of chips in the car is going to increase drastically. And we are looking at what is the forecast for the next few years. And we know that by 2030, 50% of the cost of the car will be chips related.
50%?
50% will be chips and electronics related. So it's a massive amount of chips.
Yeah.
And the impact will be great and very important. We've heard people here in the show talking about innovation. And they're saying that 80% of the innovation of the car maker is going to be driven by the semiconductor. Obviously, it's going to be very challenging for an industry that is used to work on mechanics, engines, metals. And now they're going to work with softwares, with chips, and they're going to work with other industry like healthcare as well. So it's a big, complex situation for them. The amount of stakeholders, the amount of interaction, and they need to change as well how they collaborate across the supply chain.
How are the chips impacting our safety?
That's one of the main obsession we all having. The industry, but as well the citizen as a driver, right? Because when the chip is failing on your phone, well, it's problematic, but it will not be a big issue. You change your phone. If it is media related, it will have not an impact on your life. If it is related to the radar, to the LiDAR, if it is related to how the artificial intelligence is going to compute all the data in order to make sure that you are in a safe environment, then you will have a problem.
Because of this reliability issue, the automotive industry is calling for zero defects.
Yes.
So how do we ensure, the reliability of the electronics that we're putting into these cars?
We need to have in mind two notions. The notion of killer defects and latent defects.
Okay.
Killer defects and yield is more or less under control, we can say that.
Okay.
What is really a big challenge for all of us in the ecosystem is what about the latent defects, those defects that will occur on the field. And here you see some support from the complete ecosystem about how do we inspect, how do we measure that, can we see them, and then if you see it, how you can control it.
Okay.
Today, for the chip makers, there is a gap and there is a dilemma.
Okay.
The gap is what they can see and what they need to see.
Yeah.
And we see that there is a big gap.
Yeah.
Either the metrology tools they have currently in place do not see that, and they need to invest. And then where shall they invest? Shall they invest in a metrology tool, or shall they invest in a new process tool that will make a better job actually, and or in a new contamination management strategy to remove the defects and the source of defects.
So let's elaborate on the contamination control aspect of this. So if we can prevent the defects from happening to begin with, we're ahead of the game, right?
If you allow me, I will start with what is a good contamination management strategy.
Sure, perfect.
Because a good contamination management strategy needs to follow 3 lines of actions or 3 axes.
Yeah.
One of them is the one you described.
Okay.
It's the clean delivery from the chemical maker, how it's manufactured there, how you transport the chemistry into the fab, how you clean again the chemistry in the facilities of the fab, and then how you transport it from the facilities to the point of use and the point of dispense. So this is one axis.
Okay.
But there is another axis in terms of contamination management strategy. It is the air.
The air.
The air.
Okay.
How do you manage the purity of the air in the clean room, down to the process tool, and down to the wafer microenvironment? That's the second axis of this strategy. And the third one is related to the wafer itself.
Okay.
The wafer from the wafer grower, how you transport it into the fab, how you manage the queue time of the wafer from process tool to process tool, and then when the wafer is finished, how you transport it to back end, and how you protect it from corrosion or breakage.
So this is something that the semiconductor manufacturers can surely understand, but how do we get the automotive industry to understand the importance of this and how this impacts their supply chain?
The automotive industry is asking for a new way of working together. It was a very pyramidal approach, and now they want to have the full ecosystem working together. So we are working, Entegris, we are working for the last 12 months inside the GAC.
And the GAC stands for?
Global Automotive Advisory Council.
Okay. So this is a standards organization?
It's it's an organization created by SEMI. It's not dealing with standard, but the full ecosystem around the car maker are working together, identifying what are the key topics to work together. One of them is silicon carbide, for instance. And when Entegris is part of that GAC, and thanks to that, we are interacting with the car makers. And we are working with them, and we are making visible to them how we think we can address the latent defects, how we can improve defectivity, and how we need to work on contamination control.
So to help them understand, because they get the electronics parts, they build their cars, and previously didn't really understand. They knew that they could fail, but previously didn't understand all of the ramifications of what caused these failures.
Exactly.
So is there an education component to this?
There is, obviously, and we are working with them, explaining what are the processes in the fab, what are the challenges, how to solve those challenges. We are sharing with them case studies, and we are sharing with them benchmarks. Benchmarks about the contamination management. And benchmark, I think, is a very interesting tool for the complete industry, and that's the new collaborative approach. We are basically working on benchmarks. What are the good contamination control solution for a certain technology node that the chip makers needs to adopt in order to have the right contamination management strategy.
Thank you for talking to me today. I really enjoyed our conversation, and best of luck with the NCA. We'll be following it.
Thank you very much, Françoise.
Take care.
Take care.